Thank you, Brian. I have an introduction, and let's see if we can get our slides up here. Just a second. It's a famous story that when the famous scientist came to see St. Peter at the gates, St. Peter said, "Well, what did you do in life?" And he said, "Let me have my first dew breath." Thank you. So I want to talk about how did we come to be from the scientific perspective. And so I do not, of course, have all the answers, because there are no such thing as all the answers. But anyway, I'm going to talk about the two different types of perspectives that we can have about this story. So start off with a quote from David Hoffman when he was 5 years old, who was told about the birds and the bees. And he said, "You don't expect me to believe that, do you?" So there are quite a lot of stories we've been given over the years, and some of them you might believe and some of them you might not. But the one that I want to talk about is the Big Bang to people, which is of course fun and interesting, and many Nobel Prizes have been given to working out the details. And by the way, we keep using this word "the" as though the thing that "the" refers to actually exists, but it doesn't always. Anyway, what are the questions we're up to? Do you want to be a scientist? And here's the cartoon version. Who are we? How did we get here? What are the forces of the universe? Do we have free will? And I think yes. And what shall we think and do? The previous version of the picture is this one. Same questions. Of course, an Italian artist, Michelangelo, had to draw us a picture, but we still don't understand what happened. So later on, here is William Blake on the left. He is aware of the discoveries that had happened up to then. To see a world in the grain of sand, and a heaven in a wildflower, whole infinity in the palm of your hand, and eternity in an hour. He was perhaps sad and angry about the science of the day, because people thought after Isaac Newton's discoveries of the laws of motion that surely things might be that maybe there was determinism and there was no free will and there was no space for imagination. So if that were true, that would be terrible. So anyway, they were already at odds in the 19th century. But anyway, how did I get here? Well, here's a picture of the farm where I spent my childhood. On the left-hand side there is a barn that was the home for about 20 bulls. And my dad, on the right side there, was studying the genetics of dairy cows. And there I am with my sister, who's here today. And I'll tell you a little bit about that. How did I get started in this subject? Well, when I was 6, my dad told me a bedtime story that we're made out of cells full of chromosomes, and those determine your future. Well, that was his subject. He worked on genetics of dairy cows. So long ago, we didn't even know yet about the double helix. So his dad was a missionary in southern Rhodesia, and so he was born in Africa in 1918. So I was aware of the name matter, that we have association with cotton matter and the persecution of witches, so that was on my mind from an early age. My mother's family name was Cromwell, so there's another person associated with religious activity, and it's really interesting to go to Ireland and see your family name on a billboard at every village, because Cromwell's army went and killed people everywhere in Ireland. They weren't happy about that. So anyway, thinking about Buddhist points of view and so forth for a long time. So this is where I grew up, about 60 miles north of here. That's the high school on the lower left corner where I went to high school. And we took the school bus to get there. And right away, in that high school, my parents were founders of a Unitarian fellowship. So I started finding out their point of view then. Anyway, we're jumping ahead to what happened next. In the beginning was the Word. Yes. So this member about a current church day is doing church at the St. Andrews in College Park, Maryland, where I was married to Cheryl just a couple of years ago. Anyway, I'm having a good time there, thinking about Jesus and God every Sunday. Anyway, so what is God? Well, my first wife is Jane, and she was there with the King of Sweden. Now we got to have Rebecca go for a Nobel Prize, and her opinion was God is the force that moves the universe. which in Tomatni mind says, okay, well, I'm a scientist, I want to find out about that first. So, but of course, if you want to find out what do other people be, we all have different feelings, different experiences, different definitions, and we get that word the force, a the universe, that could be actually more than that, right? Anyway, so what I'm about to talk about, there's basically 6 topics for today. There's math, which I'm not going to talk about, but it gets you relative certainty. There's the exact sciences that physicists love taking out, the very precise predictions of some things. Then there's the complex stuff where you can't make precise predictions because it's too complicated. Then there's the completely unknowable, and then there's us. So back in 1929, we got this graph that said the universe is expanding. Distant galaxies are running away from us at great speeds. And Hubble noticed this graph, and by the way, each dot is a galaxy, showing how far away it is and how fast it's going away from us. Divide the distance by the speed, you get the age of the universe. 1929, the first time it knew there was such a thing as the age of the universe. And it had been predicted by George Shoemaker in 1927 based on Einstein's equations, and George was a Catholic priest as well as a physics professor. And he got to go to talk to the Pope about this, and the Pope said, well, doesn't this support the biblical picture? And George Major, the physicist, said, no, can't use it for that. Anyway, so we've been pursuing the subject for a long time. This was the first time there was such a thing as cosmology really to even think about, and so we had equations, we had observations that we could start, but it was very speculative. So now I'll talk a little bit about quantum mechanics because it's one of the other breakthroughs that's now a century old. Schrödinger, the guy in the upper right corner, and he told us basically an equation that describes the waves. So quantum mechanics isn't as mysterious as people make it out to be. It basically says everything you see is made of little wave packets. Every atom is made of wave packets of electrons and nucleons orbiting around each other, but they're all described by equations. And if you want to know, we can figure it out a lot about them. It's not mysterious, but it is hard to measure. You cannot measure a wave. So the upshot is, everything you see of value is quantum mechanics. Quantum is wave mechanics. So if anybody says a way quantum mechanics explains consciousness, that's too quick an explanation. Because everything about you is quantum mechanics. This is a topic some people will have much more questions about, but I'm not going to spend time on it. Just to say, Nobel Prizes have to do it a lot for work out on this. So here's the list of particles, which we should call wave packets, to make it less mysterious. But we're going to skip over that too because we're going to get on to the good stuff. This is good, but not up to today. So, still mysterious, dark matter. We have plenty of things that physicists have found that are mysterious. There's dark matter, which has gravity but is transparent. There's dark energy that makes the expanding universe go faster and faster, and the Nobel Prize was given for finding that out. There's cosmic inflation, which this story would tell, and that explains the expansion. It's still quite mysterious, but it does match the observations. We do not know exactly why there's more matter than antimatter, but we measured it, and there it is. And they're not exact opposites, that's interesting. And then finally, why are the constants of nature the way they are? And the answer is we have no idea. But we seem to care. So this is a story, New Yorkers explain it quite well. Are you subject for the laws of physics? Where are the laws of physics subject to? So I honestly do not know the answer to this question. The story of inflation that I just mentioned, Massing says there could be other universes because there's some kind of substance that could erupt and produce a whole universe. It could also be that there is only one, or that this is the only one we'll ever know about. And it might be, as some physicists hope, that if we work at it, we'll find a reason why the constants are exactly what they are, and this is the only possible answer. But we're not up to that yet. So as we get in another century. So this is one of the observations that came from the Kobe satellite that Jean mentioned. What it is the map of the brightness of the cosmos. The hierarchy of heat, and still measured, comes more or less equally from all directions, which is how we know it's cosmic. But it's not exactly equal in all directions, and these little thing in blue launch represent the spots on the mat. And when Stephen Hawking saw that, he said that's the most important scientific discovery of the century, if not of all time. So why is that important to us? We wouldn't be here without those spots. Those spots say that the universe was non-uniform and there was enough gravity in some places to stop the expansion. So we're here because it didn't all expand forever. Some of it stopped expanding, flex back down to make galaxies and stars and planets and people. And we're here because of those spots, empty spots. So that's something led right to, forgot to show you a picture. Those spots represent primordial sound waves. And we're having very groovy. So there's actually an animation. You can get the sound recording that simulates that map. And it deals with very fast. So I got to go to see the keynote screen. I got my diploma off. I showed my graph over and over. And you may already be a Nobel Prize winner. So now I know we're up to something. And so since then, a lot more things have been done. This is my second project to work on. We built this observatory and launched it on Christmas morning in 2021. And it came out to observe what happened after the Big Bang, the first galaxies that we could hope to find and things like that. And so I'll show you just a few samples of the beautiful pictures we got. This is using a lens that an angel gives us, and Einstein told us it could happen. Gravity can bend light. So gravity can bend light and focus it. Once in a while we can use that on purpose to find something. So here's a distorted image of a very distant galaxy. That orange thing is a very distant galaxy with an exploding star in it. And so I just love this picture because we can figure out what happened very early in the universe. So then you can get pictures of where stars are being born today. This is the place called the Pillars of Creation, where it's a great name for things, but actually it's a place where stars are being born, presumably all with planets, because most stars have planets. And it's a whole cloud of dust, so don't have time to tell you why this is an important spot, but we got a picture. And we'll tell you in a few years how it works. We got a picture of a new star being born, and with its own solar system. We think most stars are born with a disk of orbiting material. It's the precursor of the 7 planets. The ecliptic plane is a zodiac that we have. So this is one that we're presumably in 100,000 years come back, you'll be able to see the planets. But right now you can't see it for this. Anyway, we've got pictures. So one of these days we'll tell you better how it works. So how did this all lead to us? There are basically 5 big kinds of instabilities, cosmic instabilities that lead to us. Number one I already mentioned, the cosmic inflation, which is an instability of some primordial substance we call the inflation field. So that causes the expansion, causes the particles that we have. That gravitation always attracts, which means it stops the expansion all the way and makes galaxies, stars, and planets grow. And so we can form structures, and the stars light up and produce energy flows. And those energy flows can support spontaneous heat engines, which is to say something that can persist over time with a structure that draws energy from something to continue to do it. So as an example, a hurricane is a heat engine that takes energy from the ocean and turns it into a marvelous and very destructive circular pattern of a wind. So then after that, we have organic chemistry, which also, as you know, because we're here. Then what's the final step here in this list is information being brought. In other words, we have in those chromosomes that my dad told us about, we have something like 3 billion letters in the code, and that this tells us something about how this is all going to work out. What is that translate into life? Well, it's different every time, isn't it? So complex science as well. Here's an example of the complex ones where you can sort of understand the processes, but you cannot predict, not very much. On the left, we've got the circulation of the winds around the oceans, around the Earth. In the middle is an illustration of this inside of a cell, and on the right-hand side was an example of presumably a somewhat conscious creature. That will do whatever it pleases. This was the standard joke in college class, because psychology students were wanting to study those little guys, and they do not cooperate. They knew what they're going to do, and you do not know why they're going to do it. Anyway, so this is just a reminder that there are some things that are well beyond scientific predictions, and that's an example. So, history of the universe. Well, how did we get here? We got the solar system that we know about, and we have it. So the system that geologists have worked out from the fossils, about how long did this all take? About 4.5 billion years from the formation of the solar system to us up there at the top. And it's a huge investment of effort over centuries to figure this out. It wasn't so long ago that we didn't know there was a history, and now we know all of this with a lot of detail, which if you're not a participant, you wouldn't appreciate how hard that is to get. It's taken millions of scientists and engineers hundreds of years to work out the details, but we've got it, at least the general picture. So how did life occur? Well, speculative, obviously, because our ancestors ate the evidence. So presumably there's a habitable world, and something happened with molecules, and then somehow they got concentrated enough to form something like cells, and then they got going and they life. So details cannot possibly be known. But here's an important part of the possible picture. I couldn't get enough molecules in a small spot to make them do something. So the idea here is have a little more pond, as the Darwin had actually named it, and have it get hot and cold from time to time, or dry, and you'd have to somehow concentrate the molecules onto a surface so there's enough molecules in enough place to do something to each other. So if you could have this, then it could actually begin, and then who knows what happens next. The hypothesis is that was behind it all, and here is the sort of summary of what that can now do. We have 4 billion years of continuous life, and all of our ancestors have been successful at reproduction, which is remarkable too. So there's about 30 trillion, 10 to the 30th power, that is to say, billion, how many billions? 1,000 billion souls of life today, more or less. And they are the sort of secret source of creativity, because every one of them is in business to keep reproducing, keep growing, do what they can, and so that there's a life force in them that we've had now for 4 billion years. So there's, I got a little image of an angel up there over the growing grass. So this is the fundamental structure of randomness, creativity, exploration. The cells, they're everywhere, they're doing things all the time. And we've got, each one of us have got about 30 trillion of that ourselves. So that's the sort of freest unit underneath everything. So you could talk about what do they do? Well, the communication among them, up and down in every possible way, during time. So we have now systems of these organisms, and they're organized in every possible way. It's chaotic. You don't know if it's deterministic at chemistry level, at the atomic level, but it might be. But at the end of the rate, we now have we have cells with identities, and you to track them. They are kind of agents. We wouldn't say that they have free will, because they're not conscious visually, but they do these things. They respond to their environment, they cooperate, they fight, they eat neighbors, whatever they do to live. So, some interesting people in this subject. By the way, the book on the right, I endorsed. It says in my endorsement on the cover, the universe took 13.7 billion years to produce this amazing book. So my dad was a fundamentalist preacher, and he went to divinity school, and they explained evolution to him, and he thought the basically taken over by the devil. And he said, better pay attention. And he understood the force of evolution as so important to us. And this is Farquhar's divine story. Anyway, so then he passed away. But he's grew a lot from Thomas Berry. You're on the left here. Recommend, or we came up too. So many interesting thinkers out there about the meaning of all this. So here are two of them. So who are we physically on these pictures? You'll feel very familiar, but the molecules, the not about the brain, all those things. That's what we've got as a result of all those cells cooperating with each other. And By the way, when they stop cooperating, that's the end for us. We don't individually continue. So we also might be your Cheryl's that said, "I do your haters' boots." Could be also this Cheryl on the right hand side. Could be a divine creation. Could be that we're influenced, but not knowing our divine nature. Could be the universe's way to be conscious. Many scientists are going to this out. We are obviously the apex actor-social predator. We can do pretty much anything we want to here and eat anything, live anywhere, build anything, just about if we want to. Could also be temporary. So pay attention. Anyway, this is your place to think about what we might also be. And there is God, we give that free will will be to King Kraft. But we are endowed with the most amazing thing. People think that the supercomputer in there. And we have this. Well, there's the example of just the structure of a cell, and it's already responding to the environment. It's extremely complicated. Our whole healthcare industry depends on understanding this, so we're putting a lot of effort into it with understanding the details of this. But it is an astonishing system in itself. And then you say, well, okay, our fate is determined by those chromosomes that my dad told me about. It's true, but how does it happen? It goes through this system, and nobody knows how it works at any level of death. So even though my mother and her sister were identical twins, they were not identical. So anyway, many things to speculate about. And so anybody thinks you guys are computer in your head, I should say no. Spaghetti code is the computer scientist name for bad computer code. It means you cannot tell what's going what and going to do what, and there's no way to read it and compute what. But our brains are not like that. It's not a code. It cannot. There is no list of instructions to be carried out. We are self-adjusting. We can reprogram ourselves every second. And there's no limit to the complexity. So no, you're not going to be able to upload your consciousness into the cloud. There is no such thing. So if anybody was worried about that, I don't think it's worried. So here's Stuart Kauffman, who is a really remarkable thinker as a scientist and is thinking about the science and religious questions for a long time. People had said, or I thought we could reduce our questions to scientific reason, and the answer is no, you can't. Because the things that really matter, you cannot be reduced to certainty. You cannot do what you need to do. So, especially, I think the most important one that he says here is we lack a global ethic. So, well, think about that. One day we do. Even those of us who have faith, we may not have a global ethic. So, this story, just his very words to describe what I just tried to tell you. The vast tangled bank of life, as Darwin phrased it, arose all on its own. This web of life, the most complex system we know of in the universe, breaks no law of physics. It is partially lawless, ceaselessly creative. So too are human history and human lives. This creativity is stunning, awesome, and worthy of reverence. One view of God is that God is our chosen name for the ceaseless creativity in the natural universe, biosphere, and human cultures. So he's an amazing guy. So there are, some people think, well, there are non-overlapping magisteria. I would say it's in a different way. We've got the physical world, and it has its laws of nature. Maybe it's even deterministic, but we don't know. Then there's the world of information, of patterns, of say, go on. This is this, and that was that. Main things. And that is completely sacred. You've got George Vettel, the scientist, again, and here's with our Pope Leo the XIV. I've got to go from Bien. So here was just a representation of the fact that we are powerful and dangerous and incredible. So about free will, there's a range of perspectives you could have about free will. So going from the atomic level all the way up to our social one. And I think that those scientists have been hunting for evidence of free will in the brain. I don't think it's something you could find, because it's not a thing. I think, personally, I think of free will as something we ascribe to one another. I say, I promise to do something, you say, I have free will, so you can count on me, and I will make it happen. So that's one kind of free will. If you're looking for an event in my brain to describe free will, you never find it. So, the world beyond science, basically everything that matters to us. So, in fact, you have possibly a free will or a free choice, the concept of an afterlife, all of those things are things we talk about, especially in religious contexts. But there's so much to think about, and it's not science. It's just a different subject. So, what do I suggest? Be brave. Claim your free will, because it gives you the dignity to do it. Claim the ability to create meaning in life. Claim the ability to have ethics and moral values. And by the way, even if people don't feel it, everything you do makes a difference. And that, by the way, I cannot suddenly become a tennis player. So, very two choices. So, have mercy. We don't know how things work, not really. There's a Supreme Court over there in which sometimes is merciful and sometimes not. But we cannot actually know what's going on inside. So please forgive us. So be curious. When the Vatican has had an observatory for centuries, Pope Gregory gave us the calendar that we use today because astronomers are telling it he needed to. And we still have an astronomer. There's a picture of God, Monsignor Manuel up there. He's about to retire, I think. But anyway, he studies exoplanets, among other things. And kids are from the top of what did that was and what did that is an extraterrestrial he's from. So be curious, please. Be joyful. Go to this Vatican Observatory Summer School this summer. What you are doing is meant to benefit all of us. Be generous in sharing your pursuit of knowledge. Each of you can contribute to building a more peaceful and just world. Sarsi Popio. And be grateful. I love this quote from our astronaut Jim Lovell. You don't go to heaven when we die, we go to heaven when you're born. There is a heaven, and God has given you the opportunity to enjoy the best things in life right here on earth, right now. So thank him, Jim. He's just recently passed away. He inspired. Something happened. It's not exactly an accurate picture, but something happened. And laugh. Be joyful. How do I have the strength to laugh now? I'm a professional laugher. Thank you.